Hello and welcome to the part 2 of this introduction to Azure Kubernetes Services session, which would be a demo. I hope you already got a chance to watch my part 1, and since you have hopefully watched the part 1, this would make more sense. Let's just get into the agenda, and I hope that you have already done introduction to container technology and introduction to Azure Kubernetes Services in my part 1 video. This is the demo video where we would be talking about preparing an application for AKS. Then we are pushing that application to the registry, which is Azure Container Registry. We'll deploy the AKS cluster. We'll deploy an application in AKS cluster. We'll scale application and infrastructure. We'll update an application in AKS, and we'll upgrade the AKS cluster. So this would be the demo that would be revolving around these tasks. Again, this is very basic. It does not cover all the granular and other details around Azure Kubernetes Services. There are a lot other things that you need to consider when you go into the full deployment of AKS for your production workloads in your environment. And as I mentioned in my last video, I encourage you to go and watch my AKS design consideration video. It also has an attached PDF so that you can take the advantage of all the information that has been shared with you on that presentation. With that, let's just get into the actual demo.
First phase that we have is to create a voting application, local voting application on our local Windows 10 desktop. And the steps that we would execute for doing this would be installing a Docker work desktop on Windows 10 machine. Once that is there, we'll start the Docker desktop. We'll download the application code from the GitHub, and then we'll create the container images. We'll view the images, we'll test the application locally, and then we are ready for the next step to push this application into the Azure Container Registry. Right? Make sense? Right, let's get into it. So the URL that I have presented in the earlier slide, I'm already there. I will click the download the Docker Hub here, which will require an account, which I already have it. If you don't have it, you can sign it for free, not a big deal. And then we say get Docker. We would download in, and actually I have already downloaded here, so I don't need to wait for downloading here. Docker for Windows installer exe. I'm going to cancel it and let it install. All right. So the Docker desktop installation is complete. I'm going to close it, and now we need to start the Docker desktop, and I have it here. Once I launch it, it should take some time to start it. So we're going to wait for this Docker desktop to start. It is still showing starting, so we're going to wait. All right, let's try to log in again. And I think we should good. It's up and running, right? So our next step is to download the voting application files from the GitHub. We'll try that. I need to get rid of that directory. And I got all my files here. Right now we are going to try to create the image out of it. So 1 second. So I change to the directory, and we're going to run this command docker compose upd. Hopefully that should create the required images. Should be quick. Alright, so the images and containers are now built, and we're going to see them. Here are our images. Let's look at. So you see our images are ready, our container is ready. Now we are ready to test our application locally, and that's what we should do next. And our local application is good, localhost 8080, and we have this voting applications fully functional, right? Perfect. So now we are ready to go to the next step, which would be moving this application, pushing this application into container registry. I'm going to pause it here, and then we'll just get into that. All right, our next phase is to push this application that we created locally on the Windows 10 desktop with the Docker desktop to the container registry, right? So first we would create a Azure registry. We would log into the container registry. We will tag the container image, and we'll push the image to the registry, and then we'll see that the image shows up into the Azure container registry. Right, pretty straightforward. All the commands have already been given in this slide, and now we can just dive into the actual execution of these steps. Okay. All right, the first step here is to create the Azure Container Registry. I already have created a resource group in my Azure tenant, and we're gonna just create a registry, right? I'm logged on to Azure tenant through Azure CLI, and we're gonna run the command to create the Azure Container Registry. Our resource group name is AKS, and our registry name that we are putting here is AKS ACR. It's basic. Hopefully that should run fine, and you should be able to create the Azure Container Registry. Oops, so we need to probably change the registry name. It is already taken. Let's see here. AGACR, hopefully that should go through. Ah, yes. That's funny. Hopefully this should create it. Alright, so we are good. We created the registry now, and we're now going to tag a container. But before I do that, let me just show you that how the registry is created. So you can now see the registry is Azure Container Registry is now created, and now we're going to tag it and then push the image. Alright. So what we're trying to do here is to get the login server for the registry, and once we get the login server, then we would tag the Docker images that we have created on our Windows 10 desktop, and once they are tagged, then we'll push them into the registry, right? So we am already logged into my Azure Container Registry here. If you see here, now we're going to get the server login server name, which we would utilize in our next command. This one. So AGACR list, Azure Container Registry list, resource group name is AKS. We are querying the ACR login server, right? That's what we're trying to do. And it should give us the server name, which should be generally your registry name, right? Azure CR, which is Azure Container Registry.azure. Okay, this is what we need to copy, and we'll use it in next few commands. So we have the Docker images already here. If you see here, the Docker images that we have is tagged as latest, and Python 3.6. Now we need to change it and tag it to our server name, and that is our next task. So now we're going to tag it with our server name. So as you see, that server name is login server name is azacr01.azurecr.io. This is what we are naming and tagging it. We are also naming it the version 1, because once we update it with the newer version, we'll change the version to 2 as we move forward in this lab and in this demo, right? So we'll execute this command and then see what happens. Alright, so we tagged it, and let's look it back whether we have tagged it successfully. And you see here, now the tagging is good. We see the repository, we see the tag here, right? And that is what we're going to leverage once we are going to push the image into the Azure Container Registry. And look at the command, how simple it is. We say Docker. Oops, where did it go? No, it's not what we want. Hold on. The command is Docker push, and we are giving the login server for the registry and the tag that we tagged it earlier, right? And that's all we need to do, and it should start copying the files, the image into the registry in Azure, right? That's what we're trying to accomplish. Alright, so it's going to take a few minutes. I'm going to pause it and come back. Alright, so we have pushed the image, container image, from our desktop to the Azure Container Registry. Now we can see and check it in Azure whether it shows up or not. And we can see that our image is in Azure Container Registry. We ran that command, AKS repository list. We gave the name of our container registry. The output here, please, intuitive, simplified command to say, right? So it's not rocket science. It gives me the Azure workfront. If we also want to see a tag specific image, we can do that as well. If we go and run this, and this command that we ran here should give us the version of our image, which is v1. That's what we did, right? So pretty all good, and we are completed with this phase. And now we're gonna move into the next phase, which would be deploying the Kubernetes cluster, right? All right, I'm gonna pause and come back. So when you talk about, I'm sorry, this should go back. Now we're going to create an AKS cluster, and the steps to create an AKS cluster is, first we're going to create a service principal or SPN. We're going to copy the service principal name and its ID and password, and try to put in key vault. Then we'll grab it from key vault and we will configure the ACR authentication. Basically, here is what we are doing, the RBAC, which we talked about, the role-based access control name. And once the RBAC is done, then we're going to copy the, or we already said that, copy the SPN to the key vault, and then we'll create a Kubernetes cluster, right? We'll install the Kubernetes CLI, connect to the cluster using the command KUBECTL, kubectl, right? I know how to pronounce it. That's our task, and let's just dive into it and see what happens. So the first task that we have is to create an SPN, and we're going to run this command adsp create for RBAC. That's what we are doing it, right? Service principal, we are creating it, and you can name it anything that you like. And we can skip assignment because we're going to do it in the next step. or I might have already created with this name, so we might run into an error. We'll see. Okay, so we have this app ID and we have the password here for the app ID, which probably would capture and put it into Key Vault and try to get it from there, right? So I'm going to pause here and see. So I'm going to copy the app ID and the password here in Key Vault so that we can access it through that, and then we would do the RBAC. So if we go and look into, I already created these two, app password and AKS app ID for our S secrets, and that is the value. We'll query that once we start installing and configuring the RBAC here. All right. Okay, and then we move forward. So in order to assign the RBAC role to the Azure Container Registry, first we need to identify the Azure Container Registry resource ID, and once we have the resource ID, then we would assign the SPN ID that we created earlier, right? And that's how we would assign the rights there. So let's do that. So I'm going to try to get the resource ID here. And that resource ID for our container registry is, this is string. Copy it here, and then we're going to use it in our next command. So we're going to get the app ID from the Key Vault. I have this already captured here, right? So I have got this app ID already covered here to the Key Vault, and we're going to use it in our next command. So if I go here and run that command now. So if you want to see the actual assignment here, as far as the role-based access control is concerned, the Azure CLI, we have assigned him in the ACR pull, right? That's the command we just ran and it executed it. But I also want to show you the other options here, right? So if add role assignment, there are other options. If you look into here for ACR, you have got ACR delete, you have got ACR image signer, you have got ACR pull, you have got ACR push. So depending on what role-based access control model you want to deploy, you have got plenty of built-in roles that could be utilized for proper management and operations in your environment. Right? I just want to show you that all these are available, or you could make a custom rules if the need be. But by and large, this should be enough, right? Now that's what we are done. So let's move to the next step. So the first step is that I would get the password from the Key Vault, and I'm running this command $pass is equal to AZ Key Vault secret show name app password vault blah blah blah. Once I have executed that, I would run the next command to create the cluster. So I'm executing a command here, AKS create the resource group that we have, the AKS, the name is of my cluster is a tool AKS cluster. We are putting only one count, as I mentioned earlier. We'll scale it up, down once we get into the scaling option. Our service principal, which we already got captured from the Key Vault, our client secret, which is the password that we have here for the password, and then it will generate the SSH key that are required. So it should run. It will take a few minutes because it would also provision another resource group for all of the required components to run the cluster. Once it completes, I'll show you all that. I'll pause it now. Alright, so the PowerShell command completed. I think we got the AKS cluster created. We can look into the portal, and here is my AKS cluster. It's created. It should have also created one more resource group, I believe. If we go back at the resource group level here and refresh it, right here, right? So you have got another resource group that automatically creates for all the other required infrastructure for container cluster, including the load balancer, the virtual network, the disk, right? Which is what is our later, including network security group. That's our later part of discussion. Once we go into security and compliance side, we'll talk about that, but it is all good right now here. Next, what we could do is to make sure that we are all good, we can install the CLI for AKS, and the command is, although I have already installed, let me put the command here, and then we can actually try and connect into our cluster to the command line, right? This is the one that we installed. I have already installed, so I don't need to worry about it. And then we can try to connect to our cluster through the command line, right? And let's see if we are successful. And we go here, AKS get credentials, resource group AKS, my cluster name is a full AKS cluster. Let's do that. I think it's going to ask me for credentials, but we'll wait. And just to see our nodes here that we created on the cluster, I ran the command on my desktop on the Docker side, and I looked into the command that I ran was kubectl get nodes, and it is giving me the node name that I have here. Let's check whether I'm lying or I'm good. So I'm going to go back into the portal, and if you look here, our node name that we have, AKS node pool 1, this, that's our node here, that's what is running here, right? So we're all good, and we are ready to go to the next step where we would be actually deploying the application in Kubernetes. And I'm going to stop and come back once we are ready with that process. All right, now we are ready to deploy the application to the AKS cluster. All right, I think it is very exciting so far. We are making good progress. So the first task is we are going to update the manifest file that we have on our Docker desktop that we are already running. So in order to run and update that manifest file, we would have to first get the login server name, which we also did in the last few steps. So you'll get the login server name, the registry login server name in the Azure container, Azure Container Registry. Once we have the login server name, we'll open the application manifest file that we have on our Windows 10 desktop. We can open it with Notepad, and then we'll replace the content where it says Microsoft / Azure front with our actual server name, right? And then Azure Container Registry login name, and we'll save the file, and then we'll push the application into Azure Kubernetes Services cluster. And that's very straightforward, and we'll test the application. We'll see that the actual IP address is assigned, the public IP address to the cluster. Basically, it assigns to the Azure load balancer, and then we'll see it, and then we'll test the application. Right? Perfect. All right, with that, let's just get into it. All right, so we ran the command here that we have ran in earlier phases too, AKS list, resource group, AKS, and we are going to query the HCR login server, basically the container registry login server name, which we got here, right, HCR01. And then we're also going to open that YAML file, the manifest file on our Docker on the desktop. So I ran this command, right? We are in the directory, Notepad, and we are opening this YAML file. And once we open this YAML file, this should come up here. So, 1 second. So the file is open, the manifest file, the YAML file. You have all the details if you want to quickly go through, right? So it doesn't, you don't need to, but basically this is our label here. This is our node selector for Linux. This is our container name. This is the image, the code that we are putting here. Once we go into deeper side, we probably would do a little bit more complex applications, complex containers. Azure would bang the code, blah, 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 right? So replicas is only one because we only have one node here. And these are the things that we customize when we deploy the actual production clusters. And what we need to do here is, like, you will also see what CPU, what we are seeing here, what the port is saying. It's right now it's port 80, it could be port 443. We have the SSL part of it, API version. And the thing that we need to change here is the container section, right? And we have the Microsoft. This Microsoft has to be replaced with actually the ACR registry server name, right? So let's capture that and put it here. 1 second. And we're going to replace this section with our actual server, which is AGACR01. And we are good. We just need to save this file. And our manifest file has now been updated. And we are ready to push this application to the AKS cluster, right? All right, we are now ready to do this, push this application to the cluster and the container actually. And the command was very simple: apply app Azure Vault all-in-one registry YAML, and Azure Vault front is now created. And now we are pretty much, application is there. The Azure load balancer should get an IP address soon, and as soon as we get that, we would be able to test this application. To ensure that we are ready, we're going to run this command and we'll watch it once we get that. Right, you see here external IP is pending, and as soon as the IP is assigned, then we should be good to go, right? Meanwhile, I will show you what I mentioned. So you guys see here, now this is completed. The load balancer has got an IP address which we would be connecting to test this application, which is 65.52.24.167. And if you look into our Azure resource group that was created as a part of AKS Cluster deployment, that was automatically created as an additional resource group. We have the load balancer here, which is Kubernetes. Again, this is what the AKS and Microsoft Azure managed Kubernetes services comes into picture. We didn't have to do anything by ourselves. This was all this was automatically done under the hood by Microsoft Azure, right? So that's what, if you remember the part 1, that's what we were talking about, the difference when we talk about AKS and ACS. And that's exactly the reality check here, right? And you also see now that Azure load balancer that was created during the AKS cluster creation process has this IP address, which is what we are seeing here. And now we can actually test this application in Azure, right? Obviously, when you design it at a higher level for the production point of view, you might have to put some kind of a web access firewall in front of this, because you don't want people to come directly into traffic, which is another discussion that we might have when we get into the security compliance and governance part of AKS, which I intend to present soon, right? You could have an application gateway with WAF or WAF. You could do that, or you could also put third-party web access firewall like Akamai. Okay, so let's test the application. And if I have captured the IP, I should be able to go to and here you go, right? So now our application has been deployed inside AKS cluster. It has its own container, and where this front-end application is running. And as I said, we're not going to be expert after going through this demo or lab, but at least we have a precisely good understanding of how and what the different processes are. When we go to actual production deployment, it might be more complex. There could be more component that we need to dive into, understand it, design it. But as I mentioned in my part 1, that this particular video effort here is to simplify stuff, and especially those folks who have not worked on AKS space or container space, they will find it rather easier and simpler, right? Okay. All right, so this is what the application deployment phase completes. Now we need to move into the scaling options of the application as well as the required infrastructure. When we talk about infrastructure, we are pretty much referring about the AKS cluster, and that is our next phase. So let's just dive into. All right, exciting times. So now next interesting part of this presentation of this live demo is to scale. When we talk about scaling the actual parts of the cluster, modifying the resources here, right? How much resources depending on what workload you have in production, and we'll see how simple and how easy it is, which is what brings that adaptability part of AKS, which is what makes it such such a required item by DevSecOps team, which is what we have discussed earlier in our presentation one. I keep saying that. Please do watch if you have not watched it. And we will see two portions here. We will auto scale it. We will first of all we'll manually scale it, then we'll auto scale it, and then we will also scale the AKS node. So we will add replicas here for the part. Then we will add actually the number of nodes that we talked about. Remember when we created earlier, we just created with a single node cluster. Now we are going to add two more nodes here. So we'll have 3 nodes here. And the whole purpose of this exercise here is to make sure that we all understand that how powerful, how simple, how non-interruptive these processes are, right? And that is the beauty of leveraging containers and leveraging AKS here. And let's get into that, right? All right, so we are ready. And now what we are seeing is first we are going to try to see the parts that we have deployed. And we ran the command kubernetes get parts, where you will see that we have these parts running, Azure Broadband, blah, blah, blah. And then we are trying to manually scale it, right? And we'll manually scale it with running another command. And let's run it. So we ran the command, right? Kubernetes scale replicas equals to 5. And deployment is Azure Board Front. We successfully did that. Let's see what did it do. Right, so let's double check it. And now we should see a different. See how simple it is when we do the replica and think about creating an HA portion of your application. Now we are running it in 5 parts, right? And that's the beauty of containers. That's the beauty of AKS here. And once we get into the next step where we would now do the auto scaling. So this was manually scaling. Now we'll do the auto scaling. So I just ran a command here. If you see here, AKS show resource group, my cluster, and we're trying to find the Kubernetes version. Because if this version is less than 1.10, then we need to update it, but we are good. And now we're going to update the YAML file. And once we update the YAML file, we should be able to do the auto scaling. Okay. All right. So remember when we open the YAML or the manifest file on our Docker image and on our desktop, we have identified that time when we were looking into the CPU request here. CPU was 250 micros here, and then the CPU maximum was 500, right? Now, what we're going to run here, we're going to change it to auto scale, and we were going to run the PowerShell command that if it goes, the CPU utilization is more than 50 and more than 3 minutes, it should automatically scale, right? And we'll change it. So we ran the command, and what we're seeing is that CPU utilization is less than 50%, and it is running minimum up to 3 minutes, maximum up to 10 minutes, then it should, auto scale it down. Now we initially started with 5 replicas now, and momentarily once we do that, we should probably see 3 because there's no load there on our application as of now on an AKS. But we'll double check, come back here and check whether it automatically gets reduced to 3, right? And that is as simple auto scalability that as we have described earlier. Now, next is that all good stuff, guys. I think you're liking it. Next step is to manually scale the AKS node, and then we will try to see how does that go? So as we have discussed earlier, now we're gonna scale the nodes in the cluster, and we're going to change it to 3 from 1, right? And we talked about earlier, we're going to see how good, how bad, how easy it is, and I think it couldn't be easier than this, right? We are just saying AKS scale, resource group, AKS, Atul AKS cluster, and we are changing the node count to 3, right? And that's all we need to do. And you see it's running now, and it should take a few minutes before it provisions those additional nodes there. And we have just with this simple command line, we are able to scale up or scale down our infrastructure, AKS cluster infrastructure. This brings so much ease and so much comfort, so much flexibility, so much agility that we have been talking since we started this discussion in part 1, right? And now this is all kind of a bring all the relevance, and it is actually proving what we talked about in our part 1, right? So all right, the nodes have been updated, the count has gone up. If you look into the on the screen, you will see that it has added 3 nodes, and you can go and check back on the portal. And now we are seeing 1, 2, and 3 different nodes, right? We just did that, and that was the purpose of showing you the scaling option. Now we have upgraded the pod. We have changed manually. We have changed the manual auto scaling, manual scaling of the pod, and it changed from to 5. And then we also did the auto scaling. Now let's just the moment of reality to check whether that really worked or not, right? So we said here that oh wow, so it has already gone down 1, 2, and 3, right? The front end application, where we decided that the auto scaling option is if it's less than 50% for minimum 3 minutes, then it should scale down. And we are already seeing here the benefit of auto scaling in our AKS, right? That's pretty awesome. Now we also have seen the nodes have been gone up, with just one single command line, how simple it could be, right? And that is the beauty of AKS. That's exactly what we talked about in our presentation part 1. And now we are ready to try another stuff, that we would try to update this application, this voting application, with other values, and try to push that application into the AKS, right? So let's get there. So in order to update the application, we would first modify the config file on our Windows 10 desktop where our Docker is running, Docker desktop is running, and we're going to change the values to blue, purple files from the cats and dogs that we had earlier. We'll save the file. We'll update the container image. Remember, we have already ran these commands before. And then we will test the application locally on the workstation or laptop, the Windows 10 desktop. And then once we have successfully seen that the application has been updated locally on your Windows 10 machine, we're going to tag it, we're going to push it. We have already done that in our earlier section. And we will deploy the application into AKS, and we'll test the application in AKS. All these commands are already here, so let's just get into it. Alright, so the first command is to open our config file. Command is right here. We open the config file. Here should be the config file. We're going to change it to whatever we like, and we're going to change it to, let's say, blue and red. All right, and then we will save it, and then we'll publish and test it locally. Alright, so we can see the application has now been updated. Localhost 8080, blue red, all good to go. Alright, so in order to tag this application, we need to know our Azure Container Registry login server, which we are getting it right here. We have done it in past, so I think you guys are now familiar with this command line, right? So we have this AGACR01, this information we need to capture it, and we'll be using in our next power commands. Now we're going to tag it. So if you see, we are doing commands are very simple. Docker tag. This is our container registry login server. Our version is 2 here. This is more important. That's what we discussed earlier too. Alright, so we run the command. We are pushing it back into the Azure registry, and those files were already existing. This command has successfully now completed. No errors here. We're good to go to the next step. Alright, so we checked our pods. They are good. Now we're gonna update the application, and we are running the command kubectl stat image deployment area road blah blah blah, and we are putting the version 2, the tag version that we created. The image is now updated. Now we check the pod status again. It is creating the 2 containers now, and I'm impatient. I'm checking it again, and now finally all of them are running. Now it's terminating the old one, right? So this is the good process here right now. Alright, so I run the command again, the get services Azure mode front, mode dash front, which is what we are seeing, that the public IP address is assigned to the load balancer. We are good, 65. Now we can browse the application through Azure Container Services and see that the application is upgraded. Here you go, and this is upgraded. So see that how from the CI/CD perspective, from the DevOps perspective, how simple, how easy, how efficient this was to update that application in container, right? So again, it goes back into our part 1 where we talked about it. Now it's a reality check, right? So we are absolutely feeling comfortable going this route, because this is no rocket science. This does it on the fly. Imagine if you have to rewrite the whole code, how troublesome, how painful this would have been. Alright, so now the last step that we have is to upgrade the Kubernetes, and let's just go, basically when we say upgrade the Kubernetes, we are upgrading the Kubernetes cluster, AKS cluster, and we're going to go into that. So upgrading the AKS cluster is pretty straightforward. Remember, if this process has to be done manually, this is a real pain. But when we talk about managed AKS service, AKS or managed services from Microsoft Azure, this makes our life easy, and that's what we are just gonna do, right? So no, I'm sorry, I'm on the wrong slide here. Give me a second. All right, now we are at the right slide, and we would first see what are the available cluster version. We'll check our version, and then we will update the cluster, right? Then we can validate it, and we can validate the upgrade. So pretty straightforward. The commands are already in the slide, and then we can just go and execute them. All right, so we are now running it. We are running the upgrade process, and it will take some time. But let's just try to understand what's going to happen throughout this process, right? So the first thing that would happen is that the Kubernetes scheduler is going to prevent any additional ports being scheduled on a node that is being upgraded. So that is an automated process. We don't have to worry about it. Second thing that is going to do is that it will going to running pods on the nodes are scheduled on another nodes in the cluster, right? So we have already seen that we have multiple ports, multiple nodes now. And then a new node is created that runs the latest Kubernetes component. It's all happening automatically behind the scene. And when the new node is ready and it is joined to the cluster, the Kubernetes scheduler begins to run the pods on it. And once the pods are running on the new new node there, then the old node is deleted, right? And you don't have to worry about it. This is all happening seamlessly in the background, and that is the beauty, right? And that is perhaps our last step in this our demo. We can also validate the upgrade. We can double check our version once it is completed, but I don't think it's a moot point at this point. I will end this presentation here, and once again I want to thank all of you to have patiently watching this long video, but as you know, there were many pieces, and I tried to cover everything possible from the AKS deployment perspective. I think you might have at least a good understanding now. If you have never done it in past, that is not a rocket science. It is good. Of course, we are not expert just by doing this. More you do that, more you get experience. So good luck, and thank you again. And if you like my videos, please send your comments, or even if you have any negative comments, do not hesitate, because that's how I learn and improve. Thank you so very much. Have a blessed day.